Hi, welcome to our math. Today I'm doing a series of videos on exponential equations. All right, the population of Wisconsin in 2005 was 5.54 million. By 2015, the population grew to 5.76 million. Assume that the population grew exponentially. Find the exponential model for the population T years since 2005. Okay, so the first thing we note that we have 2005 and 2015, and we want it in years. So if we start with the 5.54 that grew to 5.76, if we divide by the 5.54, we get that A is going to equal 1.039711. Now I don't know how far to go out yet, so I'm just going to write a bunch of decimal places for now. The problem is this is a 10-year growth factor, and I need years. I need a 1-year growth factor. That means I need to take this 1.039711 and take it to the power of 1 over 10. I need 1/10 of the factor. Remember, when you're dealing with exponentials, you always affect everything with the exponent. If we take this to the power of 1 over 10, we get 1.0039. Now, the second part of A says, what is the growth rate? So by the rate, you subtract 1 and multiply by 100, rounded to 1 decimal place. Well, if I subtract 1 and multiply by 100, so subtract 1, I get 0.0039, and multiply by 100, I get 0.39, rounded to 1 decimal point. This would be 0.4%. This tells me that that's the level of specificity that we want up here. So we actually want our growth factor not to be 1.0039, but 1.004. So though it doesn't tell us to round to 3 decimal points in part A, it kind of does in the second half of A. So this is where we're getting what to round to. Okay, so f of t equals, let's see, our initial population is 5.54, 1.004 to the t. So here is our model for Wisconsin, and here is our growth rate rounded to 1 decimal place. Okay. It says use the model found in part A to find the average rate of change from 2005 to 2006 and from 2015 to 2016. Round your answers to the nearest 1,000. All right. So this is in millions. This says round to thousands. That means we're going to have to do a few things. Okay. We know that the population in 2015 was 5.54 million. So let's find the population in 2016. So we'll take, so in 2016, we take 5.54 times 1.004 to the 1, because it's 1 year later. And if we put this into our calculator, we get 5.56216. And if we want to know the rate of change, this means we just literally want to know the difference. So we're going to subtract 2015. So we want to subtract 2015. 2015 was 5.54. And if we subtract these two and then multiply by 1,000,000, because we want a raw number, so we're going to subtract, we're going to get 0.022160, and then we multiply by 1,000,000. We get that the rate of change it rounded, see what does it say, round your to the nearest thousands, is 22,000. Okay, so that's the rate of change, 22,000. If you're wondering, well, we'll get to that in a second. Okay, so that's 2015 to 2016. Now we have to do that again for that was 2005 to 2006. This was 2006, this was 2005. Okay, Now we do that again for 2015 to 2016. So 2016, we're going to do everything exactly the same. 2016 is the 5.54. This time it's to the 11. I apologize that this was marked as 2016. 2006 is 1 year after 2015. 2006 is 1 year after 2005, and 2005 is a population of 5.54. 2016 is 11 years later. 11 years later, we get 5.788,694. We subtract 2015. 2015, the population is this 5.76. And when we subtract these, we get 0.0. I'm just going to round this time right away, 29000. So the rate of change on this one is 29,000. So the rate of change from 2005 to 2006 is 22,000. And the rate of change from 2015 to 2016 is 29,000. All right, so we just found the populations, subtracted them, and rounded to the nearest thousands. And the question is, are they the same? And the answer is no. Why aren't they the same? Well, rate of change, average rate of change is slope. This model is not linear. So we didn't expect this to be the same, because if it were the same, it would imply that we had a linear model. Okay, now it says use the model found in part A to find the percent rate of change. Now this is going to be a little bit easier. We have all the numbers. If you don't remember how to find the percent rate of change, what we do is we find the value at 2006 minus the value at 2005 divided by 2005. So we find f of 1 minus f of 0 divided by f of 0. So f of 1 was that 5.56216 that we calculated right here, minus f of 0, which is our initial, 5.54, all divided by 5.54. And if we calculate this out, we get 0.004. For 2015 to 2016, we do f of 11 minus f of 10 divided by f of 10. So f of 11 is going to be the 5.788694 minus 5.76 divided by 5.76. This one takes a little more rounding, but it's 0.004. Are they the same? Yes. Why? Because percent change is exponential. And this is an exponential equation. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.